Okay, let's dive into this. Welcome to today's Explainer, where we're going to unpack a genuinely groundbreaking paper straight from the Qwen team over at Alibaba. We're looking at this fascinating concept called skill self-play. It basically tackles one of the absolute most pressing bottlenecks in the AI world right now. How exactly do we push the capabilities of large language models further, faster, and way more reliably than before? So here's the core problem we're facing with modern LLM training. Historically, we've trained these massive models by just feeding them absolute mountains of human annotated data. But, what happens when that well runs dry? What happens when an AI has essentially consumed all the high-quality human data available and literally has to become its own teacher? For a model to keep improving, it has to generate its own tasks, solve them, and evaluate itself in a loop. We call this self-evolution or self-play. Sounds great in theory, right? But making this actually work in practice is incredibly difficult. You see, when researchers try setting up an AI to teach itself, they're usually stuck between two extremes. It's basically a massive Goldilocks problem. On one hand, you've got these narrow sandboxes. These are super strict environment-bound methods, like a code executor. Now, they give the AI perfectly reliable feedback. The code either runs or it doesn't, right? But that completely confines the AI's learning to a very narrow, restrictive domain. Then, on the totally opposite extreme, you have unguided generation. Here, the AI is free to just imagine any open-ended task it wants to solve. The problem there? Well, without strict rules, the AI tends to generate chaotic synthetic noise, totally ill-posed questions, and residual errors that just pollute its own training loop. So the first bowl of porridge is way too rigid, and the second is just far too messy. Section 1. The power of agent skills. To find that breakthrough middle ground, researchers came up with something they call an agent skill. It's that just right bowl of porridge. They basically figured out a way to give the AI the freedom to explore vast new concepts, but with strict guardrails in place to make sure the learning actually makes sense. So think of an agent skill as a highly organized, modular unit of procedural knowledge. It bundles up task-specific instructions, generation hints, rules, and validators all into one neat, reusable block. By organizing expertise like this, the AI doesn't just spew out random noise. Instead, it uses these skills as a structured, verifiable interface that forces it to generate logically sound tasks that can actually be checked. Section 2. The skill self-play loop. To really get how this all works, let's look at the multi-agent reinforcement learning system they built. It helps to just humanize this whole complex setup by thinking of it as a dynamic teacher-student relationship. First up, we have the proposer. You can think of this agent as the teacher of the loop. But instead of just making up random chaotic questions, this teacher actively samples from that library of agent skills we just talked about to craft a highly targeted curriculum. It uses those structured blueprints to synthesize challenging, logically valid tasks for the system to learn from. Next up, sitting right across the desk, is the solver. This is our student. The student's job is to take the tests the teacher just created. The solver explores candidate solutions, attempting to execute those generated tasks. And by doing this, it's continuously pushing its own capability boundaries. It's getting smarter and more capable with every single loop. And this brilliantly illustrates the ultimate goal of that teacher-student dynamic. If you look at the learning frontier curve, you'll see exactly what they're aiming for. Because think about it. If a task is too hard, the student learns absolutely nothing and just gets frustrated. If it's too easy, they stagnate. The proposer aims right at that sweet spot, the learning frontier, targeting a medium difficulty where the solver's success rate is roughly 50%. This guarantees a continuous, optimal rate of improvement, without the system fabricating fake difficulty just to hack the reward mechanism. Bringing it all together, here is the complete overview of the skill self-play system. We've got our proposer generating tasks, our solver tackling them, and right down there at the bottom, a crucial third component, the skill evolution controller. If the proposer is the teacher and the solver is the student, this controller is basically the school principal. It sits back, analyzes all the execution feedback, looks at the success rates, and uses that real-world data to constantly update the school's resources, meaning the skill library itself. Section 3, Evolving the Skill Library. So what is the secret sauce that keeps this curriculum from getting stale? Because obviously, if a student masters a skill, testing them on it forever isn't going to make them any smarter. The principal, our skill evolution controller, takes 3 exact steps to curate the library. First, it refines. It looks at execution trajectories from failed attempts to diagnose flaws and fix the core content of the skills. Second, it prunes. If a skill becomes so easy that it's just yielding trivial tasks, the controller retires it, keeping the AI entirely focused on the true learning frontier. And third, which is just amazing, it induces. Alongside the guided tasks, the system does allow for some open-ended exploration. When it finds a brand new valid pattern out in the wild, it extracts it, abstracts it, and adds it as a brand new skill to the library. The curriculum literally expands itself. Section 4, Breakthrough Performance Results. Now, what's really interesting about this slide is how it pivots us straight into the hard data, proving this theoretical framework actually works. So, does this proactive co-evolving skill library actually build better AI models? Emphatically, yes. Just look at the massive delta on these radar charts comparing the baseline, the old unguided self-play approach, and this new skills self-play method. On the left, we're seeing incredible expansions in tool calling capabilities. But look really closely at the chart on the right for logical reasoning. Notice something missing? The yellow line, which represents unguided self-play, it completely fails to even appear on the logical reasoning chart. Why? Because without the structural guidance of those skills, the unguided method literally couldn't synthesize valid logic puzzles to train on. It just collapsed under its own chaotic noise. To show you just how dramatic an impact this has, let's look at this specific turnaround in tool call prediction. We're looking at the Mistral 3 8B model. The base score was a pretty struggling 20.7. Running unguided self-play barely moved the needle at all. It basically sat stagnant at 20.8 because, again, it couldn't generate a viable learning loop. But then, when researchers applied skill self-play, the score rocketed to 63.6. We are talking about a massive absolute gain of 42.9 points. Skill self-play essentially rescued a completely misaligned model just by giving it the structure it desperately needed to teach itself. And for complex grid-level logical reasoning, those tasks that require strict constraint satisfaction and really unique deductions, skills self-play yielded an unbelievable 12-point absolute gain on models like Minstrel 314B. And again, to put that in perspective, this was in an arena where unguided self-play simply collapsed. By guaranteeing the structural accuracy of those synthesized puzzles, skills self-play robustly translated into advanced logical deduction. We'll wrap up today's explainer with this really powerful quote from the paper's conclusion. By using co-evolving skills as training time scaffolds, these researchers have managed to perfectly balance the scales between open-ended exploration and strict verifiable boundaries. Just imagine the possibilities moving forward. We're looking at an AI that can endlessly, safely, and reliably build its own curriculum to push the boundaries of its own intelligence. It really makes you wonder, if AI no longer needs humanity to curate its textbooks, just how fast will the next generation of intelligence evolve?